Hi there, this is Josephine. You're welcome to the channel. Today we are going to look at area and volume expansivity. Previously, we said that the expansion of an object which was observed or which was done only by the length is said to be linear expansivity. But if the object expand by the length and the width, we call it area expansivity. Or the object expand by the length, width and height, we call it volume expansivity. Okay? So if you don't know how to define linear expansivity and to solve problems associated with that, we can check that up. All right, today we're going to look at area expansivity. And when we're looking at area, so we are going to see that the object has increased both the length and the width. Is that okay? So let's see what we have on the board. Area expansivity, the symbol is beta, is defined as the increase in area per unit area per degree rise in temperature. Okay, so it means that beta is equals to increase in area divided by the original area times temperature rise. The same method we saw for linear expansivity is applicable here. So let's break this down to see what we can get. Okay, so we say beta is equals to, for us to get the increase in area, that is what, a2 minus a1 divided by a1, which is the original area, times temperature what, rise. Okay, all right, this is if I ask to find the area expansivity, where a1 is what, original area, a2 is new area, and theta is temperature rise, which is the same thing as theta 2 minus theta 1. That is if you have two different temperatures. But beta is equal to what, area expansivity. Okay, then remember that beta might not be given to you in a question, but beta is equals to 2 alpha. So it means if you are given linear expansivity, just multiply by 2 to get what, area expansivity. Then some other thing they may ask to find, they ask to find the new area. The same method I use for linear expansivity, I would say a2 is equals to a1 bracket 1 plus theta beta. This one is for what, new area. Okay, use this formula. If you're asked to find increase in area, increase in area, we say this is what, a2 minus a1 is equal to what, a1 theta what, beta. Okay, so it's just similar way, the way we added this. I've told you how to get this formula, but it's just the same thing. We are changing the L in linear expansivity to A. Okay, the same way we are doing it. All right, so the unit of beta is what, per Kelvin. Unit of beta is per Kelvin. Okay, so this is all we have to know about area expansivity. So let's go to volume expansivity. Stay tuned. So let's look at volume expansivity. Volume of cubic is the same thing as cubic expansivity, and the symbol is gamma. Is defined as the increase in volume per unit volume per degree rise in temperature. Similar way, you're just going to say gamma is equals to increase in volume divided by original volume times temperature rise. Okay, so let's expand it and see what we have. Then gamma is equals to V2 minus V1 all over V1 what, theta. Okay, now that is if you are looking for volume expansivity, right? All right, where original volume V2 is new volume, then theta is what, temperature rise, and gamma is volume expansivity. Okay, then if we are asked to find the new volume, which is V2, you're just going to say V2 is equals to V1 bracket 1 plus theta what? Gamma. Okay, that is for new volume, that is V2, right? Then if you're asked to find increase in volume, you're looking for V2 minus V1, which is V1 theta gamma. Okay, all right, just multiply these three, you're going to get the increase or the change in volume. But if you still find our V2, we can still subtract it from the original volume to still get the same answer, but this one is the shortcut. Then also remember that volume expansivity cannot be given, but they will give us alpha because there's a relationship between alpha and gamma, right? Okay, so we can say that gamma is equals to 3 what? Alpha. By the time you multiply this alpha by 3, you're going to get what? Volume expansivity. Is that okay? Alright, so this volume expansivity is also the same thing as what? Cubic expansivity, that you're dealing with cube. If you are given one side of the cube, you have to or square it, you have to turn it to the power of 3 to get the value for the original volume before you solve your problem. So let's look at some examples on area and volume expansivity to be able to explain more on how we can do that. Stay tuned. So let's look at this example. A metal sheet of area 100 centimeters square was heated through 70 degrees Celsius. Calculate its new area if the linear expansivity of the metal is 0.000017 per Kelvin. Alright, for us to solve this, the first thing we are going to do is to state our parameters. Okay, to state our parameters, we are giving the first area A1 to be 100 centimeter square, and the temperature difference is 70 degrees Celsius. We are asked to find the new area, that is what? A2. Then we are giving alpha to be 0.00017 per Kelvin. But what you are going to use is beta. Remember that beta is equals to 2 alpha. So let's multiply this by 2 to get our volume area expansivity. Sorry, so this is 2 times 0.000017. With the help of our calculator, we say 2 times 0.00017 is equals to, I have 3.4 times 10 raised to power minus 5 per Kelvin. This is my beta. Alright, so the formula for new area, that is A2, is equals to A1 bracket 1 plus theta beta. Alright, so we are looking for A2. So what is my A1? My A1 is 100 bracket 1 plus, my temperature is, sorry, okay, my temperature is 70. Then my beta is 3.4 times 10 raised to power minus 5. Okay, so remember that what you are going to do is to multiply this first before we add what? 1. So let's multiply what we have by 70. It's going to give me 2.38 times 10 raised to the power of minus 3. Okay, then I will say 100 plus 1. Okay, what I have 1.00238. Okay, then I multiply by 100. All right, so what do I have? I have 100.238 centimeter what? Square. Okay, So this is how we can solve this problem. If you're asked to find a new area, you have to state the parameters and get your beta by multiplying it by 2 alpha. All right, then substitute into the formula and get your answer. Hope you understand that. Okay, let's go to the next one. Let's look at this second example. A solid metal cube of side 10 centimeter is heated from 10 degrees Celsius to 60 degrees Celsius. If the linear expansivity of the metal is 1.2 times 10 raised to the power of minus 5 per Kelvin, calculate the increase in its volume. Okay, now this type of question we had a metal cube. Once you hear the word cube, what will come to your mind? A cube, all the sides are equal, so it means that for us to get the volume, we're going to multiply the length 3 times for us to get what? The first volume, right? So let's set our parameters. The length given is 10 centimeters, okay, but because we are dealing with what? Cube, so this is volume. The volume is L cube, which is 10 what? Cube, or raised to power 3, which is the same thing as 10 times 10 times 10 is going to give me 1000 centimeter cube, right? That becomes my V1. Is that okay? Then they gave us the first temperature to be 10 degrees Celsius and the second one to be 60 degrees Celsius. Now we are asked to find the temperature difference, which is theta. Remember that theta is theta 2 minus theta 1. That is 60 minus 10 is equals to 50 degrees C. Alright, and they gave us alpha to be 1.2 times 10 raised to the power of minus 5 per Kelvin. Remember, we are going to use gamma, not alpha, so we are going to look at the relationship that gamma is equals to 3 alpha, and that is 3 times 1.2 times 10 raised to the power minus 5. So we are going to multiply with calculator. 3 times 1.2 exponent minus 5 is equals to 3.6 times 10 raised to the power of minus 5 per Kelvin. But what are we asked to find? We're asked to find the increase in volume, and the formula for increase in volume is V2 minus V1. This is the increase in volume, is equals to V1 theta gamma. Alright, let's multiply. My V1 is 1000, okay, my temperature difference is 50, then times my gamma is 3.6 times 10 raised to the power minus 5. With the help of a calculator, we multiply 1000 times 50 times 10 raised times 3.6 times 10 raised to the power minus 5. We are going to have the V2 minus V1, which is the increase in volume, is equals to 1.8 centimeter cube. So this is how we can solve such problem. Remember that our alpha must be given, so expected to multiply by 3 to get the gamma, which is the volume expansivity. Okay, when you get it, you can now substitute it in and solve. Either you're looking for the increase in volume or you're looking for what? The new volume. Is that okay? I hope this was helpful. If you're joining us for the first time, please don't forget to like, subscribe, and turn on your notification button so that each time I send video you get it, and share it so that other people can learn from this good news. So I'm going to put up an assignment and you have to solve it and drop your answer in the comment section. See you next time in my next class. Bye.